Hello students, Miss Slyman here with your 5.5 notes. This section is sort of awkward in the unit because it really has to do with the geometry of circles and it's part of trig, but it doesn't really go with the rest of things. Anyway, we need to get it done, so here it is. So over here we need to look at definition of different circle parts. So of course the whole outside of the circle is the circumference. And we'll start with parts that include the center. So from the center, if we have two radii, so the plural of radius is radii, that makes a sector. So a sector includes the center and two radii. An arc is what is subtended, and we'll look at that word a little bit later. It's traced out on the circumference of the circle by the two radii. So either this part inside here, so this part, or the leftover part, this part out here, either of those are sectors. It just has to include two radii and a center. A chord connects 2 points on the circumference, but does not include the center. If it did include the center, we'd call that a diameter. A segment is made from a chord and an arc, and again does not include the center. So make sure you make note of that. Chord and segment do not include center. Okay? Of course, you should know the area and circumference formula for a circle. Pi r squared is the area and 2 pi r. Or circumference, of course, is also pi d, where d is the diameter. Okay, so let's look at this. Sector has radius of 14 and angle of 100. So we're talking about this sector here. Here's our sector. That's the angle of 100. If we had talked about the angle of 260, we'd be talking about this sector. So the area, well, it's the fraction of the circle, and the fraction of the circle is 100 out of 360, and then that's the fraction of the area, which is pi r squared. And just go ahead and type this whole thing into your calculator. I'm making this at home, so I didn't have my calculator app, but I just typed the whole thing in. 100 divided by 360 times pi r squared. To three significant figures, we're going to get 171. So our area is approximately 171. We don't have units, so we can say units squared. The length of the arc, again, this is a fraction of the whole circumference. So our fraction here is 100 out of 360 times 2 pi r. Again, type the whole thing in to get the approximate value. Wrong way. 24.4. And that's just single units. Okay, so thinking about that in general, we can say the area is the fraction of the circle. So the fraction is theta out of 360 times pi r squared. And the length of the arc is theta out of 360 times 2 pi r. And of course that simplifies to be theta out of 180 times pi r. Yeah, so it's the fraction of the circle. And that's if we're thinking in degrees. So we can solve some problems. Area 61 over 360 pi r squared. In this case, I'm given the length, so 65.44 equals theta over 360 times 2 pi r. So if I solve for theta, theta is going to be 65.44 times 360 divided by 2 pi. I can see here that I had already doubled it. That should have been 25. 25. Again, just put the whole thing into the calculator to find your approximate values. To 3 significant figures, our answer for the area, 10,700. I think we're told centimeters. Yep. Centimeters squared. To 3 significant figures, 150. We're going to write down the 0.0 to show that we've rounded. Centimeters squared. Okay, so if I think about angle beta in radians, well, so for area, I'm going to have the same thing. Area is the fraction of the circle, so beta over 2 pi, I'm using 2 pi instead of 360 because now we're talking in radians, times pi r squared. Well, notice this is really nice in radians because the pi's cancel. So then the area is just a half beta r squared. The length, again, the fraction of the circle, and then circumference length is 2 pi r. Well, nicely, 2 pi and 2 pi cancel. So length is exactly equal to the angle times the radius. You don't need to memorize any of this. These are the formulas in your formula booklet. Notice that your formula booklet gives you only the formulas for radians because odds are your problems are going to be about radians. So this is not one of those things that you need to memorize. All right, arc length and sector area. So area is going to be a half times the angle times r squared. And I'll leave that to you to put into your calculator. This is going to be able to be an exact answer, so you should not round. And the length is going to be the angle times the radius. And again, I'll leave you to put that in your calculator. Okay, shaded area. So area shade is going to be area sector minus area of the triangle. Notice because it's a radius, this length is also going to be 2.6. So area of the sector is going to be a half times the angle times the radius squared minus area of the triangle is going to be a half a b, so that's going to be squared, sine 2.9. Make sure your calculator is in radians mode, and you can go ahead and calculate that, I trust. So remember, this is radians. And as soon as we use sine, we need to make sure that we're in radian mode. Okay, the area of triangle ABC. Well, again, area is a half. So in this case, we're given sides B and A, so half AB sine C. This formula is also in your formula booklet. So we've got half 20 times 32 times sine of pi over 3. You should know sine of pi over 3. Pi over 3 is the big angle. That means that's going to be root 3 over 2. So don't use your calculator on this one. So we've got a half of 20 times 32 times root 3 over 2. I'm going to simplify. We've got the 2 and 2 go into 25 times. 5 times 32 is 160. So we've got exactly equal to 160 root 3 units squared. This is a case where giving an approximate answer would not be appropriate. Okay, so radius 15 centimeters, and center O, the angle at the center is 2 radians. Diagram's not to scale. Okay, this is just like the one before. So we're going to have area is equal to the area of the sector. That's going to be a half angle, r squared, minus the area of the triangle, that's half of AB, which is the same, sine of 2. And again, we're in radians, so make sure you're in radian mode when you put this in your calculator. And notice that really this simplifies to be a half of 15 squared times 2 minus sine 2, which is pretty and looks like it should simplify some more, but it doesn't really. So now you just need to put it in your calculator and figure out the approximate area. And that will be given in centimeters squared. So I'll leave the calculator part up to you since I don't have mine. And I'll see you in class.